In this problem, we'll prove a conditional statement using direct proof. So we'll move the antecedent P over as a given, and the consequent Q will become the new goal. Problem is, suppose x and y are real numbers, and 3x plus 2y is less than or equal to 5. Prove that if x is greater than 1, then y is less than 1. Now the way I would visualize this is by drawing a graph of this inequality. And so let's see if I can do that here. To graph an inequality, you want to graph the equation you get by putting an equal sign here first. And so if we do that, then I notice that if I put in 1 for x and 1 for y, I get a true equation. Right? So that means that the point 1, 1 should be on that line. And well, if you solve for y, you get, well, you're going to get a slope of negative 3/2, right? So I'm not trying to be perfectly accurate here, but let me try and draw a line of negative slope through that point. And then we have to figure out which side of that line is going to satisfy the inequality, and so we can choose a test point, for example, the origin, plug in 0, 0, and it's true. Right, so that means that the solutions to that inequality are everything on that line or sort of below and to the left of it here. Okay. And so do you believe this conclusion then, that if x is greater than 1, so if we are sort of to the right of this vertical line here, then y is less than 1, right? And that is true for any of these points that we've shaded in. Okay, they're all below the line y equals 1. So, all right, we believe this thing's true. Let's try and figure out the logic of the proof. We have a couple givens, and our goal is this conditional statement. And we're doing direct proof, so we're going to take the antecedent P, and that's x greater than 1, and we'll move it over here as a given. And consequent y less than 1 is our goal. Okay, so we need to use these two inequalities to somehow produce that one. And the only one that has a y in it is this one right here, so maybe we can solve that one for y, first of all, to get y less than or equal to 5 minus 3x over 2. And then it would be nice if 5 minus 3x over 2 were less than 1, because then we could combine the two inequalities and get our y less than 1. And so maybe we should take the other given inequality, x greater than 1, and try and build up to 5 minus 3x over 2 on the left side. Okay. So the first step would be to multiply each side by negative 3, which will flip the inequality sign around, since this is a negative number we're multiplying by. And then we should add 5 to each side to get 5 minus 3x. And then divide each side by 2. And sure enough, we get exactly what we were hoping for, that 5 minus 3x over 2 is less than 1. And so putting that together with our other inequality, we get our goal, y is less than 1. Okay. So let's write this proof out. First step was to move the antecedent over as a given, and to take our new goal to be the consequent. So we will say, suppose x is greater than 1, and we show that y is less than 1. And then to get there, first thing we did was to solve this inequality for y. So we'll just say solving 3x plus 2y less than or equal to 5 for y. We see that y is less than or equal to 5 minus 3x divided by 2. And then after that, we wanted to figure out about 5 minus 3x over 2, so we took our x less than 1 and multiplied by negative 3, added 5, divided by 2 to get this result. So we'll say multiplying each side of x greater than 1 by negative 3, we get negative 3x less than negative 3, and adding 5 to each side, we get 5 minus 3x less than 2. And dividing each side by 2, we get 5 minus 3x over 2 less than 1. And then finally, the last step was to combine our inequality for y with this inequality for 5 minus 3x over 2. And those together gave us our goal of y less than 1. Okay, so we'll just say combining this, meaning this last inequality here, with our earlier one, y less than or equal to 5 minus 3x divided by 2, we see that y is less than 1. And that finishes the proof.